So hopefully you've given those questions a go and you've got the solutions to them there that are exactly like the ones we had. What's a little bit different is if you look down here at the question 3.3 here. So have a little bit of a look at it here on page 21. What do you notice is a little bit different? It says write this in this form. Okay, so see if you can notice it straight away. It's not that big of a deal, but if you've never dealt with it before, it's going to throw you a little bit on the question. And Leaving Cert question is most likely to have something like this here. So, first of all, we're sitting down in the exam. Could be the first question on our Leaving Cert. It says, write this in this form. So we know it's completed the square. And if you've seen it already, the coefficient of the x squared, the number in front there, that's what's different. We are not able to complete the square of any quadratic that has a coefficient in front. I don't care if it's 2, if it's 3, if it's minus 78, we can't complete the square. What we have to do is pull that number outside a bracket, even if it's kind of painful. Because like a junior cert, we would call this highest common factor and it would go into everything. Here we're lucky it goes into everything, but in the Leaving Cert it might not. So look, I'll show you how to deal with this here. If I pull a 2 outside a bracket, I have x squared plus 6x minus 10. And now I'm just going to go on with just this. I'm just going to complete the square of that. And there's a small difference at the end. I'll show you that in a second. But if in another sum, say like the past paper question one, if in another sum you had, I don't know, 2x squared plus 11x minus, I don't know, 10, okay, you would have to pull that 2 outside, divide it back in, 2 into that goes x squared, but you have to divide it back in here. And that would give you what? Plus 5.5x minus 5. Don't forget this last one here. And now you'd complete the square of what's inside the bracket. We had a little bit of a shortcut for dealing with decimals earlier, so they don't really affect us. Write down the first two exactly as they are. Half the number in front of x. And that's why you need your best mate. You need your calculator with you at all times. Square it and add it on. Don't be doing that sort of stuff in your head. If we go back to the question we have here, I'm actually lucky enough that it just went in nicely here. So we've taken the 2 outside, divided it back in. We're going to complete the square of what's inside the bracket. We're not getting rid of the 2. We're just like ignoring it for a while. It's not our mate for a while. So 2's out here. Write down the first 2 things exactly as they are. Brilliant. Half the number in front of x, that will give me 3. Square it and add it on. Perfect. Subtract that number and then bring down the last piece from the quadratic. Brilliant. Underneath that, we now know that these 3 things are always going to be a perfect square, and this will just go into our calculator. Fine. I'm going to take the, even though I can factorize that, I'm going to take the shortcut here. So I still have 2 on the outside of something, but these first 3 things will turn into a bracket that has x at the front squared, and that number here is always half the coefficient of x. Cool. Again, you could factorize this one, but decimal ones in the future you couldn't. And then put these into our calculator, and again, they could be decimals or fractions, so obviously we could probably do this in our head. We get minus 19 and then close the bracket. This next part a lot of people find quite difficult, and I can kind of get it, but also I kind of don't get it. Like, I don't really understand why. The last thing you have to do is multiply in the brackets here. So like multiply 2 by the first thing and 2 by the second thing. If I bring us back, because so much maths goes back to first year, if I bring us back to first year, and I said we have, I don't know, 2 times x plus 3. Nobody on this video, if you've done the Algebra 101, should have any trouble. If I said, please expand those brackets, nobody should have any trouble in saying, well, 2 by x is 2x, and then we got plus 6. Like, that's literally the answer. This by this. Now, we didn't, like, multiply that in. You just put the 2 in front of the x. There was 2 times x, and everyone's okay with that. It's not like Twex or something. But here, when I do it, people lose their minds. We're going to say 2 by this first thing. So if I just put it up here underneath the answer, okay, so it's just, or sorry, underneath this, so it fits in. 2 by this bracket is 2 times x plus 3 squared. And you might go, you didn't multiply it. I did. Look, that bracket is gone. We also have 2 by minus 19. So 2 by minus 19 gives me what? Minus 38. Minus 38. And there we go. That's the answer there. Now, some people might be upset again that, look, the signs are a little bit different. But that's fine. We get away with that with the numbers that they've given us there. And we can deal with that later on in the year. But that is literally the answer. It says, write this in this form. There we go. Cool. So always try to simplify it back. There's our final digit. We don't have to square this out. We never want to do that. If we did square that out and add all the like terms, we'd just be back at the beginning. They didn't ask for this here, but sure, we might as well give it a go. What if they said find the minimum point? There's absolutely no difference in finding the minimum. Or if it was a negative quadratic, it would be called what's called a maximum point. There is absolutely no difference here than before. If it was minimum or maximum, zero difference. Once you've got your answer, change the sign inside the bracket and keep the outside one the same. And that would be your minimum point if they asked for it. They didn't, but if they did. Cool. Underneath there, you'll see some people need more than one go, more than one practice, and sometimes you don't want to go straight to the past paper question. So on certain things throughout the notes, you would see where, like maybe your school books, I've given you a question, and I've just given you the answer. So you can see at the bottom of page 21, I've given you a few questions that you can practice if you want, and I've given you the answer straight away. So your answer should look like what's there on the bottom of that page. But what we're going to do now, and feel free to pause the video, and don't move on until you're confident in it, by the way. What we're going to do is we're going to move to page 26. Okay, we're going to look at question 5.1. Question 5.1. And this question 5.1, I'm going to read the question and then show you how to recognise it. It says, if the roots of the equation 2x squared minus mx plus 8, so 2x squared minus mx plus 8, if they are equal, find the values of n. Now, unfortunately, a lot of people don't actually know how to deal with this, but it's not a mathematical thing. It's not that this is hard. It's just people don't know how to recognise it. They haven't been shown how to give this a go. Again, just seeing a quadratic doesn't tell you what to do. The examiner tells you what to do. It says if the roots are equal. So what that means is the roots of this are equal. So there might be x equals to 3, x equals to 3. Or x equals to minus 7 and x equals to minus 7. It says find the values of n. It doesn't ask me to find the roots. And that is what we call a nature of the roots question. So if they, write this down in red, if they mention roots in some way, shape or form, if they mention roots but don't ask you to find them, so don't ask you to solve or look for them or anything like that, it's what we call a nature of the roots question. I'll show you how to do it in a second, but just look at the next one. Question 5.2. Determine the nature of the roots of the equation. So again, it's mention the roots, but it hasn't asked you to find them. And there's ones on the next couple of pages there as well, if you wanted to give those a go. Mention roots, not find. That means we're going to always be talking about this b squared minus 4ac. This is what's called the discriminant. Now that discriminant, all the rules for that are on page 24, 25, but it's very, very simple. That b squared minus 4ac is in the minus b formula. It's the bit under the square root. It tells us about the roots. It tells us three things. If that there is greater than 0, that means the roots are real, i.e. not imaginary, i.e. like the ones we've had so far. If that is a value of less than 0, they are not real roots. They are imaginary. They are complex roots, some of you guys might call it. But if that there is equal to 0, well then the roots are equal roots. And all that means is the roots are the same. So let me just give you an example of that and then we'll do this question. This is a quadratic with equal roots, x squared plus 8x plus 16. If I was finding the roots of this, x plus x plus 4 and 4. So the roots are the same. The roots are equal. Now, if you look at this question, it says the roots of the equation are equal. They have already told me that b squared, in this question here, they've already told me that b squared minus 4ac equals to 0. They've told me that's true in the question. So I know that for a fact. I'm able to recognize it's the nature of the roots question. I know the rule. I can write that down. If you now put your date of birth into the question, you've passed it. But how do we actually fill this out? We fill this the exact same way as we would a minus b formula from second year. The coefficient of x squared is a. The coefficient of x is minus m, in this case b. And then whatever's left over is c. Now I think that whatever is left over being c is pretty important. So in this case here, a is 2, b is minus m, and c is 8. You can see the kind of letter theme even coming into this. Just pretend that's a number. What would you do if that was 7? Just put it there. We know this is true, so if we just fill that out, we'd have minus m squared minus 4 times 2 times 8, cool, and we know for a fact that equals to 0. Absolute fact. Why? Because they said the roots are equal. Now, I genuinely have a first year question. Because the question itself said, find the values of m. Find m, find the letter m. So all I've got to do is solve this. M squared, that's what, minus 8 by 8, so minus 64 equals to 0. M squared equals to 64, square root both sides, m is equal to 8. Now, 99 times out of 100, that's fine, that's the answer. But I would always, at the end of a question, and we'll deal on this more later on in the course, go back and check, have I actually properly answered it? If you look in the question, it says values of m. And sometimes the examiner uses this for a 1 or 2 mark penalty. M squared is 64, so technically m is 8, and that's like always right. But sometimes if they say values like that, you should put in m also equals to minus 8. I don't want that to take away from the question, however. I want you to focus on this here. So if it just said value, there we go. That would be fine. Perfect. So, what about this? What about question? What about question 5.2, 5.3, and 5.4, 5.5? They're all the same. What I want you to do here is, I'm going to do another one on the board, but I want you to pause the video now, read through those questions, and just show yourself that you would know why it's the nature of the roots style of question. If I just picked one of them, so question 5.3 is exactly like the one we had there a second ago. It says has equal roots. If I just pick, we'll do question 5.2 because it's the next one. How do I know it's the nature of the roots question? It says determine the nature of the roots. So determine the nature of the roots of this equation. So they've mentioned the roots, but they haven't asked you to find it. Cool. Now, some people might be a little bit daunted by all the letters, but the second you know of everything you ever learned, that it's down to b squared minus 4ac, you know that you're separating yourselves from other students in the country because you can recognise it, and you know you're on the board marks-wise. So, let's have a look at it here. X squared minus kx, I'm just thinking, what would I do if that was a number? I'm not scared of it. Minus k squared equals to 0. Okay, so that's what it says there. Cool. I know it's the nature of the roots question, but note here, they haven't said it equals to 0. Okay, because it's asking me to determine the nature. I've got to find out, is it real? Is it not real? Or is it equal to 0? So in this case, I'm just going to fill this out and see what happens. B squared minus 4ac. So a is 1, not x squared. A is the coefficient. A is the number in front of that. A is 1. B is minus k. And C, a bit annoying, is minus k squared. Cool. Just got to be really careful. I'd slow it down if I were you. If that was numbers, it'd be handy. Letters, not so great. So b squared, we've got minus k squared minus 4 times a times c. Cool. So minus k by minus k gives me k squared. Minus 4 by minus k squared. Note the difference here. That squared squares that. That squared's already on the k. Minus by minus is a plus. So we've got k squared plus 4k squared. And I'll give you a second to think. Right? Can you figure that out? Do you know what to do from here? It's a little bit random. But would you be comfortable in figuring that out? They are actually just like terms. We always got to be on the lookout for them. If that was like x plus 4x, no one would have a problem. But sometimes with k squareds you would. So we've got 5k squared. Fantastic. How do I finish it off? I've got high partial. How do I get full marks? That is definitely greater than 0. How do you know? Anything in the world squared has to be positive. Look, 3 squared is positive. Minus 3 squared is 9, which is positive. X, I have absolutely no idea what it is, but x squared is definitely positive no matter what it is. So 5 times something positive is definitely positive. That is definitely greater than 0. So therefore, if it is greater than 0, the nature is it has real roots. That's it. If we got down to a case where we had something similar, but it was, I don't know, minus 5k squared, well, because that's definitely positive and that's negative, that would definitely be less than 0, and you could say no real roots. You could say no real roots. If it all cancelled out and you just got 0, you would just say it has equal roots. No problem. What I recommend you do, though, is I recommend you try a couple here. So, look, I've done question 5.1 and 5.2. 5.3 is like the one we had before. Do either 5.4 or 5.5. How are we looking at them? 5.4 says cannot have real roots. So they're basically saying prove the discriminant is less than 0, and I won't say anything about 5.5. So pause the video now and give that a go.